So here, let's get started. This is the chapter 2, write simple programs. First, let's talk about the different programming styles. We have sequential programming, structured programming, logic programming, disk programming, and object-oriented programming. And in fact, Python will support all of it. Okay, Python can support all these. So Python is a very complete language, but we started from the 1960s sequential program. That means you have one-by-one operation. Okay, one-by-one operation. And later we have the structural programming, and we start to have something called if, then else, and then while loop, those kind of things. Then we started to do this processing, and this processing, we start to see something like add 3, 4, this type of listing that Python also has that. So that's the list processing. And last one is called object-oriented programming. And so far, this one we have not covered yet, but Python also support it. Okay. So in chapter 4, we will actually basically go over that. But these are 4 different styles of programming. And Python language right now is quite popular. And it's also evaluated to be high ranked in the technical evaluation. So these few different slices, I will run faster because these are general knowledge, not really related to Python language. So over number of top 39 computer science department that use Python as the language they use for introductory programming course. Python is the most popular one. So why using Python language? Because Python is open source, everybody can download. Okay, Python is most popular, and it is used for Google, Facebook, Uber, and many big companies. And Python is freestyle, easy to learn. Python is adopted by major universities, such as the first language to each. Python has the most feature of sequential, structural, list data, structured, object-oriented programming language. So Python has a complete language and the most popular. And I think so far, if you check the different companies, Python still be the most popular, one of the most popular languages. And then here is the sequential programming and structural programming. So far, I think you have learned this one-by-one statement. This one you learned it, and then if then else you learned it. While loop, for loop, you learned it already. Calling a function, you also learned it. So these are the sequential and the structural programming. You have learned all of these so far. So we will be just going over these. And when you do design, you can use a flowchart. Okay. So this we will cover that later. This programming, this one actually is called this programming language. It's related to Python, but not at this moment, so we skip it. The next one is object-oriented programming. Okay, this one actually you haven't started much of it this yet. Okay, this one actually not much of this, and this one will show up in chapter 10, 11, 12. Okay. When we go there, we will start to learn that. But before we go away from here, I need to let you know that the whole Python language is object-oriented programming based. So let me see. I'll try to find write a program for you for knowing what is object-oriented programming language. So first, okay, normally we have this one called A equals 3, B equals 4, right? And print A, okay? So A, B are numbers, and A, B as I said, A, B are numbers, and A, B in Python, they are all objects. So what really is an object? What really is an object? Object is like a ball, right? A ball is an object. So you can play ball. You can kick ball. Okay, and the ball may have a data called radius. Right, so you have a ball, and the radius is r, right? So these are called the features. The feature you have. So like, for example, like the ball may have a radius of 10 centimeter for baseball or something. Okay, you can hit, you can play. So these are different methods that apply to it, or functions apply to it. Okay, so we based on write program based on such object-oriented feature. It's called object-oriented programming. And in the past, we just teach you this structural programming and sequential programming. But here I'll briefly talk about the object-oriented programming with object, property, and method. So radius is a property. Method is a function that work on the object. Okay, so now these are not object-oriented programming. So here we can actually define a class called point. And then you need to have something called constructor. So you need to write, define init. Okay, and then you say self.x equals, here you can pass some x and y over here. Self.y equals y. Okay, so that will create a point. Okay, that will create a point. So for example, if I want to create a point, I can say P1 equals point of 3 and 4. That's 1 point. And P2 equals point of 0, 0. That's another point. Okay, so a point has 2 data fields. A point has 2 data fields. You have the x and y. So in your coordinate, you have certain point. You have this one, 3 and 4. And there's another point called 0, 0. So that has 2 points. Is that okay so far?
Yeah.
This is called object-oriented. So you need to declare a class. And that class actually has 2 data fields, the x and y. And you say that that point has its own x and y. And then 2 variables coming from outside to set that internal self's copy of x and y. So basically, your point has 2 data. Your point 1 has 2 data. It has its own x and y. And this x and y, we call it self.x and self.y. So when I call this function constructor init, I have a value, so this one is 3, 3 will pass to here, so it's set it on to 3, 4 will pass to here, so y with 4. And then I have the data over there. Okay, so now I want to calculate the distance between these 2 points, so I can do.
What is init?
Init is to create a point.
Oh, yeah.
So this one called constructor.
And then self is to.
Or actually create a point.
The self is to like.
Self is its
telling
own,
about the point.
The self is its own data. Self is like I have a point P1, right? My P1, I have my own x and y. So this is self's x and self's y. And the blue one x and y actually is the 2 number over here. So assign 4 to here, 3 to here, 4 to here. So the red one is the self. Blue one is the outside parameter that I assign in. Is that okay?
Yeah.
So in fact, I can, if I don't do x and y, I can actually here I put s and t, that's also fine. okay? I still assign the 3 and 4 to it. Is that okay? But
Yeah.
I use X and Y, it would be easier to understand what it is, okay?
Yeah.
Okay, now I can calculate the distance between 2 points. So I say distance, and then here I have like point X, okay? So I mean, don't put point X. One is cell, one is other, okay? So I'll say I'll return the distance will be here. I need to actually import and mass, okay? I need to import my mass function. Okay, and here I say sq mass dot sqrt of calculating the square root of myself's x minus the others x, and then square plus myself's x minus others that y. I mean self's y minus others y. Okay. So this one I say print p1 dot distance and then p2. So if I write this, p1 will be self, p2 will be other. So basically I'm calculating the x and y for self.
Oh, okay.
And x and y's other. And then this will give you the distance between the two. So what will be the number? 4, 3, and 4, and 0, 0. That give you 5.0. Is that okay? So such design is called object-oriented programming, and Python also supports object-oriented programming. So basically, point is an object assigned to P, as P1 is an object, P2 is another object, point is a class. Class is a template to generate object. So basically, I have a point class, and then I generate P1 point, P2 point, and this P2 and P2, I calculate the distance between them. Okay, I calculate the distance between them. Is that okay so far?
Yeah.
And so using the point, I can continue to generate several different points. So I can still do 0.3 equals 0.4. So then, what is the advantage of using this object-oriented programming? What is the advantage of having this object-oriented programming?
To be more specific in graphs?
Yeah, that's one thing. Be more specific in graph. Yes. What else? It makes things reusable.
Reusable.
Right? I use the point. I can easily generate a lot of different points. I don't need to write
Oh,
several
yeah.
different points. Right? Second, more organized. Instead of having like x1, x2, y1, y2, y3, y4, x3, x4, instead of having a console available, each point has its own x and y. You don't need to write a group of different x, y for different points. Is that okay?
So
So here I can also do this. I can also do print my P4 is X. Print my P3 is Y. Is that okay? So P4 is X is 7, P3 is Y is 6.
Yeah.
So number one, it gives you the reusability. Number two is correlated to some concept, say point. So it provides you some organized and give you abstraction. Conceptually, I just need to know, oh, this is a point. I no longer deal with two numbers, X and Y coordinate. I deal with a point. Is that okay? So here, actually, I can also do this. Here is a point, right? Can I do something called not rectangle. Let me call it polygon. Okay. Okay, so this polygon, actually, I save P1 equals P1. So I assign 4 points to it. Okay, so I assign 4 points to it. So basically right here, I actually can do, here I can actually do like poly 1 equals polygon. And that polygon built by P1, P2, P3, P4. Right? The polygon is built of P1, P2, P3, P4. Is that okay? And then this polygon, actually, I can do print out the polygon. And right here, I can say return. And right here, I can write another one, call this one.
I'm a little bit confused on the.
Yeah, later. You just watch, okay? Okay, I had to put that. So here I say print poly 1. Take no parameter, let me see. Take no perimeter, P1. Oh, here I'm shorted one. That's fine. Must be str, not point. Must be str. So here, let me see. Let me see. REPR, STR, STR, STR. Let me see. So here, let me see. STR, S, STR, what?
What does R the return?
Okay. Let me actually, I can actually now delete this. I don't need that. Okay. I did wrong. Oh, it doesn't allow this. So actually, I need to do str. Okay, what it is like this one. I have the underline REPR, right? You see that one? So that one actually will convert my point into strings. So whenever I have a string, actually I try to convert things to string. So here, if I have an x and my x is 3, I will convert it into string. So it becomes a 3. And left hand side, I have a parenthesis. Right hand side, I have 4. So that becomes a points coordinate. So I print out a string that is the coordinate and based on my x and y value. Okay, so that's when I print a point. So right here, actually, in my polygon, I also convert those 4 points to string. So each one will come to here to run this REPR thing to get the points coordinates and print out in the brackets. So right here, as you can see, the polygon actually I print out 4 points. So point 1 is mapping to here. Point 1 is 3 and 4. Point 2 is 0, 0. Point 3 is 5, 6. Point 4 is 7, 8. And then each one of them converted to string using this REPR function. So REPR function actually is converted to string. It's a function to convert things into string. Is that okay? So the point is converted to string if we use a REPR over here. And polygon is converted to string if you have this. So here I just print out polygon. The polygon got print out, it will be converted to string using the REPR function. So it actually will print out this.
How come it has to like how come we have to write string on every single one of them?
Because I need to convert the P1 to string. Otherwise, it's a point. Otherwise, it will be a point.
Oh.
Is that okay?
Yeah.
That's actually a point. So I need to convert it to string.
Yeah.
Okay?
Yeah. Okay.
So basically, here is what it is. So that actually explains what is object-oriented programming. Basically, you build some data and group them into objects, and then we use the object-oriented programming paradigm to help you to make things more reusable. So somebody write the point or polygon or geometrical object library, you can actually directly call it. So in chapter 4, we'll see how this is going to be more powerful. So you don't need to rewrite a lot of things by using other people's design. But now you need to remember that an object includes 2 parts. One is attribute, property, or XY, the property you have for a point. So a point is an object, and the point itself is a class, and object is like P1 or P2. They are objects. So a class point can be used to generate several different objects, and each object has property like x and y, and it also has different methods, say distance. You can calculate the distance from one point to the other point, or you can use that one underline REPR, reprint to print out a point into string format. Okay, so that this one is a very basic and simple object-oriented example, but Python also support it. Now the next one is the software development cycle. We have several different models. Number one model is called waterfall model. So waterfall model, actually you do it one by one, done like a waterfall, stage by stage, analysis, requirement analysis, design, implementation, testing, and integration. Finally, you go into software maintenance. Okay, so basically, what is analysis? Analysis is like here, if for example, I try to write a game, right? And I try to write a game that is actually a fighting game. So karate fighting game, right? So I need to have two people, and then each person I can actually have a whole library of different people that I can pick, right? And then when they fight, each fight will go into like some hit point, right? And then he can actually kick, he can actually use weapon, he can use like sword or thunderbolt or whatever. Those kind of things is actually doing analysis. Is what kind of game I want to provide, and what is the market? Who is going to play that? 15 years old, 40 years old, different requirement for the market. Is that there? And then after you know the market, after you know the software development criteria, then we go into specs. Specs is like, okay, this time I'm going to design 32 figures, right? So use that, okay? No more. You don't try to tell me that you need to create 100 figures. I don't handle that much, okay? I have to fix. Otherwise, I can never finish my game, right? So that's some specific specs. And then each round is like 2 minutes, okay? Each round fighting 2 minutes. So a game 6 minutes. That's what I want. Don't give me like a round of 10 minutes. No, it's not what I want to design for. So give me a spec. Give me something that I can work on. Okay, if you just like designing a car, if you want a minivan, it's a minivan. Right? If you want to build something called sports car, it's a sports car. I need some spec. Okay, after the spec is fixed, and then the next one is like, okay, let's do design. I know 32 figures, so 4 women and then 28 boys, right? Or whatever. Each figure should have some hit points, some super weapon, something. You have to actually go into those detail things. And then when will he die? I mean, what those kind of things, and also when we do the fighting scenes, what are the backgrounds? What are the thunderbolt, and what are the music I need to play? Okay, with that all information being determined in the design stage, then the next one is implementation. I need to write each Python code to support it. Okay, and then I designed it and implemented all the Python code already. The next one is what I need to hire somebody, say a high school kid, to play the game for me. So test it, and then see whether it's fun or not. Okay, the hit point is too much, so then no one can actually die in a short time. Okay, that's not good. That's adjusted. So that actually is testing stage. And you may go into the testing, come back to refine.
But the waterfall one doesn't have a...
Doesn't have the fallback. So this one is actually older model. So this one actually go into the loops, right? Nowadays, nobody actually do 100% waterfall model. So it become like this one called cycling model. It's called software life cycle design life cycle. software design life cycle. Okay, SDLC, software design life cycle. Okay, so actually you go into here for many iteration, right? Until there's a good version, you decided, okay, let's roll out and then send for production. But even in production, you may go back to change the spec. You know, okay, in 1.0 we design something, but you know somebody criticized. Okay, that's accumulate. But half a year later, I'm starting to refine my spec and redo this. You know what I'm saying? And then finish. Okay, roll out 2.0. Okay, stay another 3 months. Okay, come back. Let's do 3.0. Okay, come back to 4.0. Something like that. Okay. So there's a software review cycle, software maintenance cycle. So there's a software cycle, or you do waterfall model. But waterfall model just tell you what are the steps. What are the steps you need to take when you develop your software. And there's another one called V model. V model is like, okay, similar to waterfall model, you do it one by one, but implementation stage, coding stage is in the middle, not at the end. So here, for example, I finished some small code, so I do unit testing. Right? What is unit testing? Okay, I just have this guy, and I can move that, move right. So that movement function is a small unit, and then let me try to test that. So I designed it, and then I have a small movement testing as well. Okay, and what is subsistence testing? Subsistence testing is like, okay, I finished the fighting scenes. Okay, so let's play this, only this. Okay, only these fighting scenes, and let's test for it. And then what is subsystem, bigger subsystem requirement, and then do subsystem test. Up to here, it may be, okay, you can actually choose a figure into the choose figure, and then you actually come back, or you can pause and then change your route or something, those kind of things. You do test with your fighting scene, see whether those are integrated correctly. Okay, after everything is tuned up, your system level pass, you go to acceptance test. What are the acceptance tests? One is called alpha test, the other one is called beta test. So alpha test is like, okay, I finished my game, so I look for in-house people to play for me. So okay, I hired 70 people to test it. Right? That's in-house acceptance testing. And then the next one is beta testing. Beta testing is like, okay, I make it free for 2 months on the internet. Everybody can download and then play it. So you hear of the Microsoft Office beta version, that means they release for general public to evaluate. So beta version usually is already quite mature. It's ready to be used, but it just needs an official kickoff date.
So like to see if there's anything to improve?
Yeah, or something that they don't find it in their lab, in their inside alpha testing. You know, for example, like somebody, I wrote a game, right? That's target for Windows 10. But somehow there's a guy whose computer is like 5 years old, and he is only had Windows 7 or something, right? But he insists he wants to play. So there's something like a system compatibility issue, or another guy who wants to do Linux, okay? And he wants to make sure that his game can, your game can only also play on it. Or another guy who is using Windows 10, but he actually only buy 1 gig memory, and your system actually, when you are doing it in a house, at your home, you are testing it with 16 gig memory, but that guy actually have 1 gig memory, but he got disappointed by your performance. Something like that. There are a lot of different combinations you never know. Or another guy who actually divided his own hard disk into 4 parts, A, B, C, D, E, F, G drive, or whatever. And then your program just doesn't work well for some reason. I don't know why, but
Bad computer or something like that?
Yeah, so everybody's setup are different, but you cannot repeat like 200,000 different combination in your alpha test, right? But if you actually roll out as a beta version for people, general public to test it, then they are able to pick up those problems, and
So,
they will feedback. So
yeah.
usually you will see the Microsoft will ask you, are you willing to participate in some testing program or something? In that case, once there's a bug happening, they will report to their center, and then they will pick up, okay, write a report and know, okay, this is not what we want. How can we tune the software and then continue to work? Is that okay?
Yeah.
Okay, this temperature conversion, we finished that, right? So this one, just let's go. Okay, so here, the only thing I would like to talk about is that in this program, you have that different functions and different a program to organize it. It's called a module. The next one is called reserved word. Reserved words are the words that you cannot use. Say you cannot say return equals 3. No way, this is not okay. So reserved words is kind of the language instructions that actually need to be used for Python language only. So you cannot use force. You cannot use force equals 5. That's not allowed. Those kind of words that reserved for Python only is called reserved word. Is that correct?
Yeah.
Okay. And the next one is expression and statements. Okay. So when we write a program, a program in Python is called a module. So you have this one called, say, this one object one. The one I just wrote is object1.py. That is actually a module. It's just like in English, you write some essay or article, right? And then under the module, you may have some functions. And this one is similar to a paragraph in your essay, right? And then you have a statement. So statements like A equals B plus C. And this one is equivalent to sentence in your essay, right? And part of a sentence like clause or phrase, we call it expression. And in each individual variable, we call it ID or function ID. In here, we call it words. Is that okay? So that's the different program levels, size of the programs. Okay, so here we talk about what is a statement. A statement is a complete comment, a line of comment that perform one certain task. Okay, expression doesn't finish the whole task. Expression actually just give partial result and then assign to some variable, right? So you can print expression is common expression, but you need to have a print function with that expression to make a statement. So variable equals something, a equals 3, that is also a statement, but 3 itself can only be called a term or a expression.
So like expressions like kind of make up
true or not true, like A plus B can be a expression, right?
Yeah, that's an expression.
But 3 itself is a term or is a factor. It's also considered to be a expression. Is that okay?
Yeah.
So this type of expression, we call it arithmetic expression. Especially you have A plus B type, we call it arithmetic expression. These are called arithmetic expression. But if we have the if A greater than 3, that one give you a Boolean value, true or false. We call it a Boolean expression. Is that okay?
Yeah.
Okay. So one question. Did you get your home textbook already or no?
I downloaded it.
You downloaded it, but had you started the homework? Last week I assigned you the chapter 1.
I did most of it, but like some of them I didn't completely understand.
You didn't completely understand, but you still need to send whatever you have.
Oh,
So
you need
that
to send the questions.
you need to send you an answer. I don't need your question.
I mean the answers.
Yeah. So for example, true or false is just write down in Word or something. Handwriting is also okay, but you need to write something, send it to me. Is that okay?
Yeah, okay.
And then I have give you like 3 or 4 different question or problem in the textbook as well. You need to write those programs. Otherwise, how can I know that you don't know something, right?
Yeah, okay.
Is that okay?
Okay.
Okay, but this week at least work on this chapter 1 and chapter 2. We will finish chapter 2. Okay.
Yeah, okay.
Okay. So be sure you do it. Otherwise, I cannot help you. Just listen to these different lectures that help you too much. Okay. So the next one is assignment statement. Say we can have this one x equals x plus 1. So what does this x plus 1 means? Actually, I have an x, right? And then my value plus 1, I become, say, here is 3, I get 4. And then that 4, I assign to x. So it multiplied back here to make it 4. Is that okay? So this is assignment. So this equal signs, actually, we usually call it becomes. All x got assigned by the OX plus 1. Okay. And for equals checking, we in Python is 2 equal sign. This is a logic operator. So this totally mean different thing to single equal sign. Is that okay? Hello, is that okay?
Yeah.
And we also have this plus equal, slash equal, percentage equal. Remember that?
Yeah.
So what does this mean? The first one. What does the first one mean?
It's x plus 1. I mean, increased by 1.
Yeah, okay, good job. It's actually the same as this, okay? This one's called increased by, this one's called divided by, this one's called take modular by, okay?
Yeah.
Remember this different thing. It actually means, sorry. It actually just means x plus equal 1 equal, actually equivalent to x equals x plus 1. And then here, if you have minus, it actually become this, okay?
Yeah.
Okay, so what the assignment do is that you get the value of your x, okay, and then assign that to a register, and then a temporary register, and that temporary register increased by 1, and then you assign the value back to x. That means you have an x value assigned to temporary value plus 1, okay, and that value assigned back to x. Is that okay? That actually, these two actually equivalent to this. Is that okay?
Yeah.
But I think it's too, it don't, yeah, that's what it is. Real computer will do that, okay? The next one is assign input and simultaneous assignment. So we can do input and then assign to name. So what type of data you actually obtain by using input, enter your name? What type of data you will get from here?
Like just a string.
Yeah, actually it's called string. It's over here, okay? But if you want to convert it to integer, you need to do assign input something to x, okay? Or you use a convert it to floating point number, you need to do this, put input in there and convert it to to y. Okay, and you can also use eval, but eval will determine whether it's x or y for you. Okay, and Python also allow this called simultaneous assignment. So I have a equals 3, 4 equals 4. So I have this one sum and difference equals x plus y, x minus y. This one will be 7, this one will be minus 1. So sum will be 7, difference will be minus 1. Okay, they can do this called simultaneous assignment. But in Java or C++, they are not allowed to do so. No such simultaneous assignment. Okay. And the next one is simple introduction for loop. So here you have some sequence. This one in Java, we call it for each loop. So for each variable in the sequence. So here, for each I in the range list, so for this range function will generate something called 0, 1, 2, something up to 9. Something like that as a tuple, multiple tuple. And then every time you get one by one, starting from 0, 1, 2, up to 9, and then do this chaos function. Remember the chaos function that time? In chapter 1, we talk about the chaos function that give you a value between 0 and 1. Remember that one?
Yeah, yeah. Isn't that like binary or something?
No, it's not binary. It's between 0 and 1.
Wait.
Let's go back to chapter 1. Okay, let's go back to chapter 1. So here, actually, let's go back to chapter 1. No, this is chapter 3. Let me open the chapter 1. Oh, chapter 1 is not listed here. Let me actually bring up my Python. So here, chapter 1, let me actually bring up chapter 1, okay? So let me see, chapter 1. Yeah, remember this one, chaos? Do you remember this one?
Yeah. Yeah.
So that
It's
the one we
generation.
see is just part of it, okay? So that actually is to generate 10 different x, and each x is calculated by the previous x. Is that okay?
Yeah.
And the next one is the flow chart for the for loop. Okay, so each time actually what you will do is like use every time you get the I and then do the scene over here. So every time you get an item from there and then assign it to the variable. Say here the variable is I, so each time you get the item from the list and then assign it to I, and then use that I to do the body. Body would be whatever line up under the for loop. Whatever line up for the for loop, this one's body. So this one I is the variable equals something in the previous chart. Okay. It will keep running until you run out of your item in the list, in the sequence. Is that okay? That's the for loop we have here. It's called for each loop. And later we have different for loop and we have different for loop structure in other language. Okay. So then the next one is the specification for future value. The future value is actually related to bank account. So you have some principles. Say initially I save $1,000, right? And then my interest is like 1% every year. So the first year, after the first year, I should gain 1%, right? So gain $10. Is that okay? The second year, I should get 10 times 1.1 and 1.01, right? So it become 1010 1.01. Okay, so it's 0101 0101. So you end up with 010201, and then second year take out 2 decimal points. So you actually has $10.20.1 after the second year. Is that okay? And you continue. So that's a so-called compound interest. Compound interest. You actually use the original principle and then multiply by a certain percentage of the interest. And every year you use the new principle to calculate the next year's principal. And so it will grow like this. It's not like a line like this. Every year you actually the interest. If you keep the same interest amount, you actually grow like a staircase like this. But if it is not, you will grow like this. Okay, that's called compound interest. Are you okay with compound interest?
Yeah.
So right here, I can read in some value called initial principal, right? And then I read in the second number for the so-called percentage, right? And then actually every year I multiply. So the code is like, first I print out the program of the 10-year investment. So I get the initial value, principal to principal, and then the rate to APR, right? And every year my new principal is based on this value. So here I can also write, I should also be okay to write principal. I can also lose a principal times equals 1 plus APR, right? Is that okay? Is that okay?
Yeah.
So that is the future value 1. Okay, of the future value 1. So we finished chapter 2. Let's go to the future value 1 program, okay? So here is the future value 1. So basically, let's run it. So initially, my initial money by $1,000, right? Each year I have 1%. So after 10 years, I accumulate like $104, $105. Is that okay? So this is chapter 1. We close it. Now I give you the chapter 2 homework. Chapter 2 homework, you work on all of the multiple choice and true and false questions.
All of the multiple choice to.
And the true and false question. Yes or no question. And then do exercise 5. Do programming exercise 5. And then you go back to your exercise. So basically, number 5 is you modify this one called future value according to the requirement. Is that okay?
Yeah.
Because you have done the doing math for Python, so this one should be easy. Okay. So here it said Python has 5 data types. This is from textbook, okay? So it said that Python has only 5 data types: integer, long, float, string, Unicode. In fact, Python only have integer, and long actually is the same. So there is nothing like this. Python only support integer, but integer can be any format. So these are the normal other languages of definition, not for Python. And Python only have float. There's nothing like this. It can support anything else. And then string or Unicode. This actually only string. So Python actually only has 3 primitive data types: integer, float, string, and the fourth one is Boolean value, true or false. Only 4 types, 4 different data types. Is that okay? It's not 5. It's not like the how many bytes. It doesn't care how many bytes. Is that okay? Let me show you. Let me show you why it doesn't care how many bytes. Okay. Let me show you why I say that Python doesn't care how many bytes. So here, let me show you. I create a new program. This one called big number, right? So initially I had like a equals 1, right? And then I say for I in range 0 to 200, right? A time equals 2, right? And then I put in my A, right? And here I say step okay? So I have such a simple program. And then let me run. So you can see that the number actually doesn't, you can continue to do that. It will give you some result. So there is no 5 bytes, 8 byte different limitation for a variable, integer variable. So there is no long or integer, no, there's not something like that. So Python actually will automatically handle it for you. So you actually can do such a big number in Python. So here, if you don't like it, put 400, it still work. So Python doesn't have a fixed number of integer, the limitation. Okay, this one actually is too long, it's too long, way too long. Is that okay?
Yeah.
You can put as many digits as you wish in Python. Okay, this is show you can do this. So there are only 3 data types. 4, I'm sorry. Boolean, string, integer, and float, 4 different types. Okay?
Yes.
And the next one is the floating point number. Floating point number is using the IEEE 741. I think this is too hard for you right now, so let's skip. Okay, you save for your like AP course or something. So floating point, let's skip it. And this different data type. Say right here, you have the different character is all string. So Python simply to group everything into one same data type. Okay, here you group the whole thing together for integer and long. Okay, and the double and float group them into the same type. And then string and Unicode is actually only one type. Okay, same thing for here. It's the same type. So only 4 types for Python. Okay, next one, special feature on data, no data type declaration. So Python language is different from other language. Other language you need to declare data, so you need to have integer x equals 3, integer y equals 4 in Java. Okay, in Java it will be something like this. So let me go to like Java language. So here, actually, the previous one, this one I show you to print out some big data, right? If I write this something in, Java, what will it be? Let me actually print out Java to write it for you. So you will see the difference between these 2 languages. Okay. So let me bring up my Java. So let me write a program, but later I'm going to delete it. Okay. So here, let me also do something called, no, let me not doing this. Let me actually create a new project. Go to your Python course, go in essential, put in your lesson. Here, let me create a new directory called, this one, let me call JDev, Java Development. And here, let me put here, and I create something called chapter 2 demo. And in chapter 2 demo, I create something called big number. Okay, so for the same program, if I draw it, write it in Java, it will be something like this. So I have the same program. First, I need to declare some program. So public static void main. I need to declare a public function for main function. After that, I need to do data declaration. Declare that A is an integer, right? And then I do int I equals 0, I less than 400, I plus plus. And after that, I say A multiply equals 1, and then system.out.println. And here say step plus I plus 1. Okay, same thing. That's not doing the 400, that's too much. The 240 step. Let me see what's going on. Here I put the phone number, let me put 2, okay. Here I cleared it and run again. So as you can see, it grow up to about 32-bit. It hit the boundary for integer. After that, it no longer can go. It go back to 0 and it can no longer go. But how about Python? Python can keep going until 400 different digit. That the multiply and ship for more than 400 steps is still okay to do, right? But Python, Java just cannot handle that many steps. But somehow around here, 38, this one, this 1099 something. Let me see, 40, 31, I'm sorry. Up to 30, this 107, this one is okay. 31 start to break already, right? 31 it become negative numbers. So 31 is actually buggy for Python already, Java already. Is that okay?
Yeah.
Is that okay so far? So data type, you basically have a number string list, number string boolean, okay? And then I talked about a list and tuple before, okay? So that part is okay. Now the next one is the operator. So what are the operators we have? We have plus sign, minus sign, multiply sign, divide sign, and 2 stars. 2 stars is exponential, right? I talk about this, right? And absolute value double slash for integer division and percentage sign for remainder, right? And then here are different library function and constants. So for pi, it actually means pi. Lowercase e actually called epsilon. It's approximation of the natural log base e. And then you have square root, sine function, cosine function, tangent function, those different functions. And log is log base e. Log 10 is log base 10 algorithm. Okay. So here I don't spend that much time over there. And the next one is the change program. Okay, so you basically okay, let's look at the change the py program for chapter 3. I think I don't have this, so let me actually create this. Okay, let me actually create this. I don't have this change the py, so first let me actually let me see, in my chapter 3 demo, I need a chapter 3 demo. So here chapter 2 demo, let me actually create a new project. So right here, let me create some directory called chapter 3 demo and create it as a directory. Okay. And here let's do change the py. And right here, change the py. Let's actually copy it over. And let me copy this whole thing over as well. Okay. So when you copy it over, actually some problem you will see. Some problem is like this double quote is not right. Okay, so let's do this. That's because the Microsoft Word converted double quote. So here, let's put into one line. And here, the total value of the your change is. Okay, like that. Okay. Then actually now I can actually run. Right? Okay, so it's a change counter. So let me have 4 quarters, 3 dime, and 2 nickel, 6 pennies. So that actually give me what? 4 quarter is $1, 3 dime, 2 nickel is 4, and 6 penny. Okay, that give me the number of these. So here, if I change it to $, right? And then let's say percentage 6.2F. And here to be the percentage. Okay. This one actually will print to a better format. So here like 4, 3, 2, 6. Okay, I'll give you $1.6. Is that okay?
Yeah.
And then I copy this guy over. Right, because this one is actually ugly. Let me actually just pass it. Okay, and then I can delete both of them. Kind of adjusting it, okay? And then I can put here with this new and nice looking chart. Oh, I'm sorry. Okay, that's what I want to do. Okay, and let me see. Okay, so that's the code for change. Okay, so the output will get, oh, quite close. Okay, and then in case 2, you try to create a quadratic function. Do you know about quadratic function? You haven't finished your algebra 1, right?
No.
So let's skip it. Okay, let's skip it. This one too hard for you right now. So math library. Math is a library. So basically, if I want to calculate the square root, I actually need to pull this one called import math, right? So math is a module that somebody has written down for me, right? So when I call the math module, I can actually do here for math.square root to calculate the square root of my 2 points distance, right? So that actually is a library. So here I can import math. I can also from math import something. So what's the difference? This one is I can actually save and quit. And right here, let me see this one, quit. Okay. Demo 2. Okay, so right here actually, for example, right here I have used this one math module, right? So here I can actually do import math. That's one way to import. It's just like this. But this way of importing, I import just the module, but I do not import the SQRT. So I need to write this. And there's another way I can import is actually I can also import this call from math import star. Okay, in that way I don't need to do math star. This one will work. That's the importing of the feature from the math library. Okay, and I also can do here. I can also just import the function SQRT. And if you improve the wildcard star, actually the program will take more space because you import everything into your computing space. But here I just import square root. That actually is better. So you can do this, or okay, you can do this one. And when you do this one, you must put the name, the module, the name of the module, math that over there. Is that okay? So then we can run. If you from math import something or from math import everything, actually it will be fine. So here we have the 3 ways of importing. One is import by a module. So the module name you still need to keep it. You import it, but you do not open the namespace, so you still need to keep it. Second is that, okay, from some module I import everything. So I'm going to import every name that defined in that module math. So in that case, my random actually, I don't need to write math.random. I write math is fine. I write random will be fine. And also you can also from math import star. In that case, import every function from your math library, the math module, so that not only random, but square root everything, you will be able to call it. Is that okay?
Yeah.
Okay. So that there are 3 ways of importing. So the next one is a range function. Range function gives you some certain range of data, right? So range 10 actually give you the data from 0 but less than 10. So it gives you the data of 0, 1, 2, 3, 4, 7, 3, 4, 5, 6, 7, 8, 9. Okay? And then if you have the range of 5 to 10, the starting value will be 5, ending value will be 10, but not including 10. So it will be 5, 6, 7, 8, 9. Okay? The next one is like 5 to 10, but step size of 3. So you have 5, 8, and then stop because the next one will be too big. Okay? Is that okay? So one single parameter range function will give you the end value. 2 parameter, it will be start and end. 3 parameter with start, end, and the step size. Okay. So here we have a factorial function. To calculate a factorial, we try to actually enter a number n, and we try to calculate the factorial stuff. So here, let me actually again copy this one to my program. Here I just do this one called factorial. This will give me n factorial. Okay, say I type in 5. This one is what? Let me see. The whole number. 5 factorial should be 5. So it's time factor every time, starting from n down to 1, but not including 1. So actually, initial value factorial is 1, and then it times 5. Oh, I have a typo. It's not face. It's called fact. Okay, sorry. So there's a bug. So 5. It give you 120. Okay. So in my original node here, face is wrong. It's a typo. Okay. So here actually, initially you read in the number called n, right? And your fact originally is 1. Then what you do is like this one actually can be simplified as fact multiplied by factor. Okay. So originally I have 1, and then it times by 5, 4, 3, 2, 1, but not including 1 because the last one is up to 2. So actually it's 5 times 4 times 3 times 2. Okay, and you will actually print that out. Okay, that's calculating factorial. So factorial actually is you have a number n factorial, it will be n times n minus 1 times n minus 2 times 2 times 1. Okay, is that okay?
Yeah.
Okay, so this one probably not hard. We probably already discussed it in doing math already. So that one is okay. The next one is machine limitation. Machine limitation actually right here for Python actually is more flexible already, but it's still, if you actually continue to multiply the number, you will go into the non-number or overflow problem. Okay. So for example, let's try our machine limit. I don't know how much it is, okay. But here in our big number, okay, I calculate up to 4,400. Let me do this. Quite a big number. See whether it still can do or not. I'm not sure whether you can do or not, but let's just try a big number, 40,000. Look like it slowed down, right? After the number get bigger and bigger, the speed start to drop, right? You know, go like the first few thousand now, okay, way slower now, right? Way slower.
Yeah.
It should become slower. As the number increase, actually slower because the calculation start to be longer every time. But it's okay up to here, still not too bad, had not break yet. See, keep going. 31,000 now. So there are certain machine limitations. We don't know. You have to check. by running some program to see what is the machine limitation. Okay, up to 40,000 steps, it still survive. Okay,
Oh, wow.
how long is the data? I don't know actually. It's really too long. Okay,
Oh.
that is really long. The numbers are really long, but it still survive. You know, it still survive up to there. So it's chapter 3. We know the limitation. Okay, and sometimes like last time when I do the calculation for change, right, it should be 1.46, but somehow if I do not leave in the number of bits, it will have the little 2 at the end, right? So that's called compilation error, because the floating point representation is not exact number you will see. So it may create such things called compilation error or digitization error. Okay, so that's 2 limitations. One is overflow, one is like losing the precision. Okay, and then conversion, you can convert integer to float, float to integer. That's easy. And you have the using the integer float or data type conversion. And you have a rounding number, serial number, and floating float function. Rounding actually is like between the range of n.5 to minus n minus 1.5. You will end up with n. Okay, serial you will round up to a larger number, integer number, and then float function you will round down to the closest integer. Is that okay? Now, again, I finished the chapter 3, answer the true, false question, multiple choice question, and then copy here the exercise.
Do the discussion too?
You can do if you want. This one is optional. Is that okay?
Yeah, okay.
You can do it, send it to me, it's fine. But the only thing important is that work on the problem 129, okay?
Yeah.
Okay, then see you next week, okay?
Okay, thanks.
Bye now.
Bye.